Hi, I'm Cheryl. In this problem, we're going to be using an iterated integral to help us evaluate the area of the region bounded by the curve y equals x, going from 0 to 4. Now, in order to do this, it's helpful to write in what we call a representative element. And you can either write in a representative element that is oriented vertically or horizontally. The choice is yours. So for this first example, I'm going to begin by looking at a representative element that is oriented in a vertical fashion. Okay, so the first thing I need to do is build up this representative element. So I'll be looking at little pieces to build up that rectangle. Now notice that the width is going to be a change in y. So for my area, I'm going to write this as the iterated integral dy dx, because I'll have changes of y to build up my rectangle, and then I'll be taking my vertical rectangles from left to right, changing the value of x. So the order of integration is dy dx. Now, I need to fill in my limits of integration. So again, remember, first I'm filling in for the change in y. So I'm going to be starting at 0 and moving up to y. Now remember that because my variable of integration is a y, I eventually want the inside integral to be a function of x. So even though this is length y, I want to write it as a function of x. In this problem, I know that y and x are the same thing. So my upper limit of integration here is an x. Once I've built up my representative element, I need to move from the left to the right. This time I'll be moving from 0 to 4. So now I'm ready to evaluate this iterated integral. So I start with the inside piece. Because my variable of integration is a y, I'm going to be treating any x's as if they're constants. Well, there aren't any x's in this problem, and the integral dy is simply y. So this is y evaluated from 0 to x. And then I still have my dx. Plugging in my upper and lower limits of integration, I'm going to have an x minus 0. So the result is just an x, and I still have my dx. The inside integral is done. I can now move to the outside, so I'll be integrating x dx, which I know is x squared divided by 2. And I'll evaluate that from 0 to 4. Plugging in my upper limit, I'll have 16 over 2, which is an 8. And then I'll subtract what happens when I plug in the lower limit, but that's just going to be 0. So I found that the area of my region is going to be 8. Now, in this particular problem, I set up my representative element so that it was vertical. You could also set it up in a horizontal fashion. So let's try doing the problem again using a horizontal representative element. So this time, I'm going to set up my rectangle in a horizontal fashion. So you can see when I set up the iterated integral, and I'm building up this piece, I'm going to have changes in x. So my area with my iterated integral, I'll be integrating with respect to x first, and then after I do that, I'll build up my representative elements in the y direction. So let's go ahead and put in my limits of integration for this. Thinking in terms of the change in x, I'll start here, which is a horizontal distance, and I'll go to 4. So it's easy to see that the upper limit here is going to be a 4. But where do I start? Well, the distance from here to here is going to be a horizontal measurement, or in other words, it's going to be measured in terms of x. But I would like to have that inside integral all in terms of y in the end. And I know x and y are equal to each other, so my inside integral will be going from y to 4. How about the outside integral? Once I've got that representative element built up, I'll be going from 0 the whole way up to 4. So 0 to 4 for my outside integral. Now I'm actually ready to do the integration. So I'll integrate from 0 to 4. The inside piece, the integral of dx, is just going to be x. So this will be x evaluated from y to 4 dy. So I've got the integral from 0 to 4. Plugging in the upper limit, I'm going to have a 4. And subtracting the lower limit, I'll plug the lower limit in and I get y. So I now have the integral from 0 to 4 of 4 minus y dy. Integrating with respect to y, I now have 4y minus y squared divided by 2, and that will be evaluated from 0 to 4. Plugging in my upper limit, I'm going to have a 16 minus 16 divided by 2, so that's 8. And then I'll subtract what happens when I plug in the lower limit. But notice when I plug in the lower limit, I just get a 0. So the result is 16 minus 8, which is 8. Notice it didn't matter whether I set up my representative element vertically or horizontally, I got the same answer. You may find in some problems that orienting your representative element one way or the other is easier, so you can choose. I hope that was helpful. Thanks.